Well, good morning. We are going to be talking about domain and range today. First thing I do want to talk about is relations. So you've probably discussed this before in Algebra 1, but a set of ordered pairs can be shown as a table, a mapping, a graph, or it can be expressed as an equation. Okay, so the set of x values is called the domain, and the set of y values is called the range. And this is the important part that we're going to talk about today, is what is domain and range, okay? A relation with distinct points is called discrete. We really won't get into this too much. And a relation with connected lines or curves is called continuous. So a relation in which each element of the domain is paired with exactly one element of the range. So that is a function. So if we look at a set of ordered pairs here, let's look at 0, 1, negative 5, 2, 6, negative 2, and 5, 7. So if you notice, each x value is its own value. It doesn't repeat at all. If we look at something that's not a function, so let's look at another set of ordered pairs, so negative 7, 2, 6, negative 1, 6, 2, and negative 3, 9. This is not a function because my x values repeat, okay? Graphically, a function passes a vertical line test. So if, let's say I have this graph here, it's a linear function. If I can draw a vertical line anywhere along this function and it only passes through the graph once, then it's a function. If I look at something like this, let's say I have a circle and I draw a vertical line, it passes through this function or this graph twice. So that is not a function. So let's look at some examples here. So find the domain and range of each relation, then determine if the relation is a function. So your domain, it's your x values. So in this first example here, we are going to list our x values from smallest to largest. So our x values here are negative 1, 0, 4, and 6. And so that's how we're going to list them. Negative 1, 0, 4, and 6. That's our domain. Our range is going to be the y values, again from smallest to largest. So I have negative 9, negative 5, 3, and negative 2. So I will list those as negative 9, negative 5, negative 2, and 3. So there's my domain and range. Now, is this a function? Does an x value repeat? The x's don't repeat, so it is a function. Let's look at our second example here. So 5, 2, negative 3, 4, 5, negative 6, and 8, 0. So our domain is going to be our x values from smallest to largest. So I have negative 3, 5 twice, and then 8. My range is going to be the y values. So 2, 4, negative 6, and 0. So I'm going to have negative 6, 0, 2, and 4. And this one is not a function because I have an x value that repeats. Let's look at what a table would look like. Okay, our domain here is going to be our x values, smallest to largest, so negative 4, 0, 2, and 7. And our range is going to be the y values, so negative 8, negative 1, 3, and 3. So I don't write it twice, I just write it once. Is this a function? Do any x values repeat? No. So this is, in fact, a function. Okay, let's look at a mapping, which is like these two ovals here. So my domain is going to be the x values. So negative 4, -2, and 5. The range is going to be the y values, so 0, 3, 7, and 9. Is this a function? Well, if you look at the mapping, you have an x value that goes to two y values. So technically here you have the points 5, 7 and 5, 9. So my x value repeats. So no, that is not a function. Let's look at the graph. So if I look at number 7 here, and I want to find my domain, I just look at the x values. So the x values represented here are going to be -3, 0, 2, and 4. Okay, there is a point way down there. The range, now that's the y value. So range bottom to top. So we have -5 here, -2, -1, 1, and 4. Okay, now is this a function? Graphically, does this pass the vertical line test? Well, if I draw a vertical line through those points there, it hits twice. So no, this is not a function. Let's look at number 9. So on number 9, the domain, the x values that are represented. So on your graph here, so your function starts here and then it just goes that way. There's nothing over here in the x values. So my domain is going to start at whatever this value is and go that way. So 1, 2, 3, 4. So this is -5. So that means we can say, or I'm sorry, -4. We can say that our domain x has to be greater than or equal to -4. Okay. Now why is it equal to? Because there is an actual value when x equals -4. Okay. The graph actually hits that x value. The range. Now those arrows mean that the function continues in that direction. So the range is actually going to be all real numbers. Okay, and we write it like that. Okay, so it's like an R with an extra leg. Now, is this a function? If you draw a vertical line, yes, this will hit twice. So is it a function? No. So next, with these examples, you're going to need to use your calculator, your graphing calculator. So if you tried to graph the function y equals -x squared plus 3, you would get a graph that looks like this. So 1, 2, 3, be sitting right there. It'll look like this. So those arrows means that it continues forever. Okay. Now, the domain, the x values, is going to be all real numbers for this function here, because I can plug in any x value into there and I will get a y value. I can plug in 1,000,000 and I'll get out a number. I can plug in -2,000 and I'll get out a number. Okay. The range, my graph doesn't go any higher than this point here, which is a +3. So that means that my y values have to be less than or equal to 3. Is this a function? Well, if I do a vertical line test, it goes through only once. So yes, this is a function. Now let's look at number 14. X equals -1. On your graph here, if you were to graph this, x equals -1 is a vertical line. So the domain is the only x value that it has is -1. The range, well, this line will go forever, top to bottom. So your range is all real numbers. Is this a function? If I draw a vertical line, is it going to go through more than once? Yeah, it is. So is it a function? No. And this is just a little bit about domain and range.